Okay, hello everyone, and welcome again on ArchiDiaries with the live interview series that is going on currently. The interview series is titled as Technology in Architecture, Innovations and Explorations. And I'm glad to share that today we are going to have the fifth interview in this series. And in today's interview, we are going to talk to a very interesting personality from Bangalore, and Mr. Manjunath BL. He's a structural engineer based in Bangalore, and he's going to be our guest today. And we are also joined by Professor Gurdev Singh and Professor Bhairav Patel, who are with us as expert panelists to generate the discussion towards the end. So let me start with you, Manjunath. Hi, welcome on ArchiDiaries. You're mute, can't hear you.
Hi, good morning. Good morning to everybody. It's a
Good morning.
pleasure to be here. Yeah,
Thank you so much.
thank you.
Gurdev sir, welcome again. It's pleasure to have you back on this platform.
Thank you.
And Bhairav, welcome back again in this series. And your involvement in this series has been really, has generated a lot of good discussions. And we are hoping that today also your insights will be able to generate some really good discussion going. And welcome again on this platform.
Thanks for inviting.
So, uh, the format is going to be the same. We will invite Manjunath to make a presentation. He will make a short presentation to begin with, which will then become a catalyst for an interesting discussion towards the end of the talk. So, before I hand it over to Manjunath for his presentation, please allow me to introduce the title of today's talk that Manjunath has chosen is An Engineer's Sketchbook. Manjunath BL is an engineer based out of Bangalore. He heads his own practice in the city since 1994, having built up a portfolio of works and sketches that encompasses some of the most exciting buildings being built today, where he is seen often primarily as a conceptual co-author as much as a consultant or collaborator. In his own words, the work of his practice stems from a vision for the role of engineering in design and of design in engineering shaped by humanistic rather than simply technical principles. In this talk, he will focus on the trajectory of his practice and working methods, as well as his evolving stance as a structural engineer involved in the complex and multi-layered task of building. Manjunath, I think the discussion, the title of the talk, I think sounds for a very interesting presentation. And before I hand it over to you, please allow Ashna. I'll hand it over to Ashna so that she can introduce Professor Gurdev and Professor Bhairav Patel.
Good morning, everyone. Professor Gurdev is a graduate from CEPT University, Ahmedabad, and he is not only an architect but also a designer and teacher and a builder, someone who builds with hands. And with 45 years of professional and teaching experience in different institutions in India and Australia. He has received a lifetime achievement award in teaching by Australian Institute of Architects ACT chapter in special recognition of contribution to architecture education. He also held the position of Dean at SEDA, Navrachna University, Baroda, and from 2011 to 2018. And currently, he is interested in exploring new and lightweight materials and technologies. Uh, Professor Bhairav Patel, who's here with us today, has an experience of more than 13 years in the profession of structural engineering, and he has a bachelor's degree from Nirma Institute and a master's from CEPT University. After having gained valuable experience in design while working with VMS consultant for 4 years, Bhairav started his own practice in 2012. Since then, he has got the opportunity on working on projects involving a variety of materials like glulam timber, rammed, bamboo, masonry, etc., along with conventional concrete and steel. He's fond of teaching and has been involved as a visiting faculty at CEPT University, Ahmedabad since 2009. So, without further delay, I would ask Mr. Manjunath to please begin with his presentation.
Oh, thank you. Let me share my screen. I think I will straight away go into the presentation. Yeah. I hope you can see the screen.
Yes, we can see your screen.
I think today, basically, what I'm going to, basically start talking is about uh, as an engineer, having worked for architects, just coming from the college and then looking at working for the requirement of the architect. You also start uh, developing some sort of skills and some sort of the hunger to know beyond, beyond engineering. It has been my the way uh, of my approach, and then that's how I started to have an office. So sketching was more of drawing out my emotion onto two dimensions, just to understand my sensitivity. What do I, what is this, of what is my own thinking, is been my journey. Okay, so today I will talk about something which is really bothering me to an extent where to decify, to remove things what is not required and see what is the essence of in everything for that matter. Okay, so let me take you to the first slide. Yeah, yeah. So I think I'm very curious. See, if you look at you know uh, the first slide, invisible forces need to be understood from the effects and the pattern. You see the effects as patterns in nature. When I look at the mountain, or if I look at the serration on the sand dunes, what are these? What is the effect of this? What is the effect of the waves? What is this pattern? Why does this pattern happen? So this pattern is the understanding the pattern through you know to the unseen, the forces which is not seen, like it can be wind, it can be temperature, it can be a pressure difference. So how do I relate from what I see to the something what I don't see? Is that is the search for me. My search is basically on this, from the visual to non-visual. And then how do I get the right questions for to get more questions? That is how the process of understanding as part of our office. Just understanding this whole sequence is being uh, like, you look at this, you look at the geology, the rock formation, and the erosion of the rock, and then it also gives you an indication of either the wind or the water. By looking at the erosion, you can identify what was the force, what was the movement of water, what are the forces, like you can basically start thinking beyond what you see. That is what is very important, very curious to me, in the sense that you see to get into a mode of seeing what you don't see, is what is very interesting in our works. So and what is also curious to me is a plant. Just look at a seed. It's if you look at this video, it's so interesting. It's so interesting that the seed is such a small thing, but it has it just goes through. Yeah. What is next? Yeah, I think this is just a video just to just to provoke you in the sense that something which you don't even see. If I talk about a seed is dictated by two forces. One is sunlight and one is water. And basically the seed is intention. So these two forces basically dictates two opposite forces which keeps it in tension. Then finally one is going towards the ground, which basically talks about anchorage, heaviness. The other one, which is going towards the sun, is becoming lighter. So these two, by looking at this analogy, by looking at this tree, so there is a duality in this earth. There is a duality. There is something which is seen and unseen. There is something which is heavy and lighter. There is something which is concentration and less concentration. There is surface and then there is porosity. There is something which is basically binding together. you know. So there is something which is constantly, seamlessly moving, the day and the night. So what is this seamlessness? The seamlessness to me is more or less can be visualized as a spiral. It's just moving. It's just moving. It's continuous. So this seamlessness has become an integral part of my thought process and my life. Like you come to office, you work, then you go home, then you come back. So there is a continuous energy, which basically makes us to evolve. This is what makes me very interesting, and also curious. Okay, and also gives me some sort of an energy which is like a child. It's like a childlike energy which is always making me to unsettled, not satisfied, to know more, to play. This is what is something which helps me to create. This is very interesting phase which I am going through. So so what I'm saying is, to me, is like, since the subject is about technology in architecture, to me is not about tectonics. It's not like looking at it's not a jewelry in a building. It's about, there has to be a depth to the requirement of these details. Because we design these details so that it is not seen, but it performs. So to me, technology is seeing the unseen. You understood what I'm saying is, seeing the unseen is, to me, is the technology. Uh, so I think it's very curious. Like when you are in the mode of thinking, and then you have a project on hand, and you don't need to go anywhere. Like you have paper, pen, you sketch. You are in a different world through the mind, but there are small, very interesting elements which are around you. It's like then you look at these elements in relation to materiality, and then somehow give life to your sketch through materiality. Either you look at a stone and then keep that in position. Just feel that. Somewhere you need to balance the dream with reality. Somewhere you have to hold. That this sketch is about. You can't dream endlessly, but you have to come back and then hug this earth. It's like you need gravity. The sense of gravity is so important when you are dreaming anti-gravity. So somewhere you have to be rooted to ground. So this is something which I thought I should explain you, because visually it is nothing but a paper and a boulder, but I have something else in this. So so these are few sketches which are you know which explains me beyond these lines. There is a particular rigor in this. There is a thickness. There is a story behind it. So sketching has become, sketches are very integral part of me. So so and and then the other question which also bothers me, like today there is so much of development all over the world, like, and like, I would I would uh, I'm scared even to even dig the earth. I don't know how do you touch this earth. How much of excavation you can make. And can we make an excavation? Do we need to build a building? So how do we touch this? Art has been a very, it's very, it's a question. It's a concern to me now. You know. So if at all I have to do, how do I do it? Okay. So like these are monoliths. Like today, you see as part of the history, you see huge monoliths. Okay. So people entered these places either through carving. So the need dictated the greed actually. Like there was a necessity. So the necessity dictated the carving. Okay, today you look at, the greed has overtaken the need. You build beyond your requirement. So how is this, you know how people used to carve these places, considering stone being stable as part of the gravity, and then today we build buildings, continuously spreading this mother earth. So it's a question. I'm just posing a lot of questions here. Okay. So and then how do people build buildings? How do people build buildings on the hill? Today, do we need to build buildings on hills, on mountains? Okay. Then if at all you are allowed to build the buildings, what should be the building? You have to think that you have to plane the ground into horizontality and then repeat the building what you build on planes, or you respect the terrain. Can you make a wound in a hill? You can't make a wound in a hill, because it allows the water to percolate and then demolish the hill. So if that is the intention, how do I do it? So these are my thoughts, in the sense that, very interestingly, there are engineers who have done very interesting thought process in this. Like, like if I look at this sketch on the left hand side, where where the same analogy of building on a hill is also represented as a different form if you were to build it on a plane, because of different functions. Because this is a structural interpretation, in the sense that
Proposition.
if the if the if the building on a hill needs to have a support which is normal to the slope, okay, how do you interpret by linear members? So you have members which are concentrated to the upstream,
Architecture books में
okay,
books का
whereas the members which are going towards
नहीं
the slope,
words
okay,
हाँ
will be always more perforated and more transparent for the reason that you have to see it outside. And what happens is to make this concentrated member which are more stiffer toward the upstream, if it were to confine, if it were to be normal to the slope, you need to pull it down. In the sense, you need to induce tension. So what does that mean? In the sense that the long columns are not compression members. Long columns are all tension members. So sometimes most of the architects visually they see it and then they say, when that guy can do thin members, why you can't make thin members? Because they're unaware of these members are subjected to a particular force. So tension members are always thin. So it is not, there's no slenderness in tension members. You are pulling it. Okay. So these are not compression members at all. So the same analogy, if I were to talk about at the next sketch, the earlier sketch, where very intelligently the Herzog Demerong, when he did when they did a stadium in, I think in Germany, so they created a bowl which is basically, is for seating. Okay, it's a stadium, and then to confine, to make it more stable, or to make a force which is normal to the inclination of the raking, you need to pull it down. You need to confine it. So the peripheral columns were once again thin. So we were thinking that how can the column becomes so thin if it were to support the structure for that large heights. So we are once again confused, like we need to look at this through a force. You need to look at the force and then replace that with material. Then you are very comfortable, because this physics is the unseen. You need to understand the unseen to create a wonderful structure. So so these are some of the explorations which we thought we should basically put it on this presentation to see what is concentration, what is perforation, and how does this concentration has a relation to the shorter heights, okay, which also gives more stiffness, which allows the long column to be tension member. So you need, if the compression member has to be confined with more compression, you have to pull it down. You know, so that is the whole principle, and so these are some of the exercises which we did. So this is, I think, as an outcome of this whole questions, I think you also come out with building. Somehow you can't only do research. So somewhere you need to build it the way you think. Okay, so this is one building which we did as on a hill in Kunnur. It's called as a walking building. It's a building which basically has two positions. As when you are walking on a hill, so when you are, one leg is in compression, the other leg is in tension, which balances the compression. And this is so beautifully working out, so that so you can move on the hill without knowing. Okay, so we took that as the analogy, and we started looking at to build this building. And this building is about 8 years old, and we did this with very small small elements of material, and combined it. So we call this like steel weaving, like working with small elements which are unstable to make it stable through a combination of small elements. So we started with the two elements to start with, from the pile foundation, and then it allowed the other two members to come into picture, and then finally it becomes one. So there is a concentration towards the ground, then it is like it's suddenly it becomes lighter as it goes higher. So that clearly takes the path of nature. So So concentration towards, so it is more heavier, so it is more anchored into the ground, and it is showing the sense of, when you look at this building, it shows some respect to gravity, some respect to gravity. Okay, and there is also a twist because of this movement. Twist always has the ability to stiffen it. If you look at the sketch on the right hand side, the bottom, you can see these two member, moving in two direction to create a twist. A twist always helps to make the building movement. So this is more of an anti-gravity building wherein stiffness takes over. So I'll go to these are some images of the building. So this building is about steel and wood, and it's ground plus one. It's built for a young couple. The architect is from Bangalore. His name is Karun Kumbera. He had just come from France, and then he wanted to create something. So it's like we said, let's do something interesting, with something which is part of the hill. Which is part of the hill. I don't want to, make the side flat and then build. Let's do something which is interesting. So this is also very curious. This is some experiment. So as part of the office, as part of the research. So how do I look at, how do I look at heaviness, okay, as part of lightness. So lightness is dictated by folds which are part of the stiffness. And then, to me, this, when I look at this building more and more, I get more thoughts. This building looks like, to me, as the essence of a tree. The essence of a tree. The essence of a tree is like, you make it the opposite of a tree as what you usually look at it. Like, you look at concentration as part of touching the ground, and then perforation as part of going towards the sky, because the only thing is it allows the sun to come and contact the soil. That is the intention. Okay, here, when I look at it more and more, so I see this, the whole heaviness is being is being more or less fused or melted, which gives an indication of gravity. By looking at the shape of this bow, it also gives me something what is not seen. You know, something which is embedded, which is gravity. By looking at this, I can visualize gravity. So this helps me to see what is not seen. And but to for common man, this is a planter box, or it can be air. So what we created, this mock-up is not for the planter box. Finally, we are using this as a planter box, okay, or it can be a bottom, but actually it's a house. It's a house. This is this is a research project at the office, but we are still waiting for the client to come. There's no client here. Okay, the whole project is documented and then done, where you have some tanks and then everything at the bottom to create a weight. Okay, and then there's a pool on the top. Okay, and then the housing is in between, and you enter from the bottom. So you enter the house from the bottom. But yeah, we are still waiting for the client. There's no client here. So this is very interesting to me. Next is a project which we are on the final stages. This is a mock-up. This is about this is how it's like a tree. It's like a rain tree. This is an installation which we are going to do it in Indonesia. This is huge. It's about 7 meters by 7 meters, and this is also visualized in such a way that how does this spread, which is a spiral, which also is very geometric, okay, which emerges from a concentration, which has a relation to gravity. What is this Like, I think this is a fantastic example of the quote of a physicist is, gravity is the hidden geometry of space. Geometry, what you see on the top, has a relation to gravity. Okay. And so by looking at the shape what you see, I can see what is below the ground. The spread of the forces below the ground has a greater similarity of the outcrop of the geometry what you see on the top. So it's, I think, one is it's a product what we create, and what we foresee is what we see is beyond the product. Okay. So this duality of seen and unseen is very curious to me, in the sense that, you know the product becomes secondary, but the thought process of looking at the unseen gives me a continuous energy to go further. So that is being an exercise at the office. Yeah. So this is one interesting project which we are doing for Francis Kerry from Berlin. So this is a project in Bangalore, but this is the opposite of Serpentine Pavilion. Pavilion what he did in Serpentine Gallery, where the columns were coming from the center and cantilever. Here he has done the opposite. So this is a marriage destination. This is about 40-meter dia. It's a huge space. It's like a net. So the perforation, the hole in the center, has a great relation to creating a stiffness. How does the stiffness dictates the whole structure? It's a sag. It's basically a sag. And how does this variation of density to achieve stiffness? So it's like we have done a lot of analysis. And what is the size of these members? The size of the members maximum is about 40 by 80. So it's like a mesh which is very organized, very intelligent mesh. And this you see in nature. This is like a cobweb. This you see in nature. Same thing. There's nothing what we are doing as humans. Actually, it's all done. It's all been done with a material which just disintegrates. So I think we are nowhere. Because when you look at nature, we are nowhere. Even we are not point, not 1%. We are not achieved anything. So if that is the hunger, if we create, I think there is a possibility of some innovation which can happen in India. So these are some dispersion and connection. This is like, how do you move? How do you move? How do you move effortlessly? Okay. Can you move without supports? Okay. Is the question. Yeah. Can I move without the supports? Okay. So it's like that. No, it's like, it's just questioning this whole thing. Just playing with gravity. Just tweaking gravity, and then harassing gravity. It's like that. Like, how do I do that? So there's also one project which we did is like, this is for a client. So he wanted to put a small retreat in one of the farm. The architect came here, sir. How do we create something which is so transparent, okay, which is being used most of the time in the day, okay, more like a pavilion, okay, which is like a shade. And you have places which comforts, are bedrooms and toilets on the top, okay. How do I make almost invisible supports, okay, so that this more or less looks like as though it is in the air, it's less floating in the air. So this is a true anti-gravity structure. So what we said was, let's use elements which are thinner, okay, but thinness should, a combination of thin members should combine to become a stable wall, which is a perforated wall. So how do you make it Stable perforated wall is only by creating stiffness. So you play like a barcode. You concentrated few elements of smaller size and then look at check their loads and slenderness. Can this member be staggered in such a way that a member which is thin can can be drawn into tension to confine the other concentrated members. So it's some sort of a dialogue well within which we went through and then created this structure. This structure we built it at around 1,000 rupees per square foot, nothing else. And then the whole curtain, the whole skin was with weld mesh, and then we placed Aerocon blocks. Just place Aerocon blocks in a pattern such that it creates shade, and you can pour water, it absorbs moisture, and then it allows to breathe, and then keeps it cool. So it's simple. You just you wear a perforated skin around you. You know. So this is one of the exploration from the out this about 3-4 years back we did this, and then we started. So this basket weaving, like I was very curious that a person who is not educated, is not a scholar, is just on the roadside with the kid by the side, she knows how to choose these fine members, okay, and then with high level of concentration she creates a marvelous basket which is 100% perfect through geometry, okay, and then the shape is done, and it becomes rigid. So how does this element which is unstable, okay, through combination with a particular rigor can create a very stable form, okay? Can I do something with this? Can I do something with that? Is there a possibility of intelligently weaving mentally, in the sense that why do I need to physically look at it, okay? So why can't I start using my brain to weave steel structures? So this was one of my thought process, and then we started doing this type of exercises to create how do you connect it, how do you create friction, what are the materials which I can use which are very close to wood, can I use aluminum, can I bind it, can I do something, how does this help, is some sort of a exploration we started doing at the office. And then we looked at that time we had we got a chance that set of like group of friends who are mainly architects. We decided that we'll start a college, and then so I was given the responsibility to build the structure at a very economical price, and then this thought process was going through, and then we started using small elements to create a structure which is more user friendly. You can feel it, you can hold it, and these sections are available in the market. It's seen, it's all, every human being, it's not like 200 300 by 300 box sections. It's all about 60 by 70 by 72 by 72 box section. We started creating this, and then creating stiffness in both directions by staggering it, and then creating stiffness through shear, like shear. You connected the joints with shear locks, okay, and then taking extra tension through steel wires, okay. So we started exploring these possibilities, and then we created this structure. So there are some few images in this. So it's simple. It's like the welding is so man-made that why can't it go layers, a series of layers. You see this assembly, all these are straight elements which are positioned in such a way that you create a stiffness around the knob. And then how do you lock it? It's more like a wooden detail, you know. So, and then you lock the column. In the right side, you see that the column is locked, and then the same tension member at the bottom gets goes up and connects the to create a partial fixity at the junction on the top. you know some of these so some of the images I will show you how does the purlin becomes the truss. Okay, how does the purlin bends to become a truss. Okay, so the way you do origami by creating stiffnesses through bending the surfaces. Why not a purlin is also a surface. There's a rhythm to the purlin. How does the purlin becomes a concentration as a truss, and how do you look at that, as a structure? So this is what I call it as a seamlessness in the whole system. You need to. There is no abruptness. Like you have a column and a beam. The column can become a beam. The beam can become that the beam can spread into a slab. That is what the nature taught us. How do I look at seamlessness? As seamlessness is part of the growth. To me is like seamlessness is part of evolving also. Yeah. So the way we build also should be somewhere very close to that. So these are few images of that. So this is also one of the project which was by the architects is to build a building in 2 months. This is in Cochin. This is in Cochin for Binale. This is about 2 years back, I think. Yeah. So after the floods, I think they wanted to build this whole, auditorium at a very fast pace so that it is there for 3 months, and then we can reuse these materials. So the intent was here is to work with one element which is unstable. Okay, a seed which is unstable. To an extent, it is made stable. Okay, but if I combine this seed, okay, in a particular pattern, okay, I enclose it with a space, okay, which becomes rigid by itself. Okay, so this is some of the models which we did, and this is what is the structure. So what we have to innovate is only the junction details. How do we detail it? And the central area is made perforated with a very natural material, which is bamboo. Okay, and the whole thing is covered with a polypropylene sheet. Since it is done for 2 months, you can see all the dust, everything. What usually is there, which you don't see, was seen as part of the roof. So it was basically controlling the sunlight. So it was very interesting space. So these are some of the exercises which we do with interns. The office, there are as a setup of the office. Even though we are strongly engineering based, we have there are a lot of curious architects all over India. They come to learn engineering. They come to learn engineering. So what we do with them is I spend about at least 6 hours daily with them, just to take back to history and then start questioning. So this is a building which we did as a dry construction, as a process. There's no client here. This is just an exploration. So you create it's a building which is not, it's like independent by itself for water and then power. So we have water tanks which are embedded as part of counterweights. Okay, then you create sections wherein you confine the brick masonry, because all these brick masonry are dry jointed. It doesn't have any mortar. So the fixity is achieved through induced tension, which basically confines the brick. Okay. and then this whole structure, this is how this whole what you're seeing. And then these are basically like pods, like each bay has three pods, which is basically for an architect who is part of the architecture course. He can stay there. He can basically do his working there, and then he can cook there, and then for 5 years he stays in these capsules. Okay. And then it has a solar panel, and it's very simple. So we did in 30-40 side, we did about 9 capsules. Okay. uh, as a dry construction. Tomorrow, if I want to remove this, I can slightly detach the tension, remove the bricks, sell it to the you know to the market, and then get back my money. That was the intention. So that I'm not permanent on this earth. So compression through tension. This is also one of the exercises for the students is, okay, so most of the cases you love to be part of the paddy field, but you can't be because of the marshiness. So how do I enjoy the paddy? So why not we create monoliths, which are just concentrated, heaviness as part of it. Then why can't we suspend something with the concentration, a very light perforated, a common space where you can enjoy below, you can be part of the whole nature. So we started, articulating these bars, which are usually available in the market. Structurally, how do I create stiffnesses? How do I create brackets? How do I use the roof to confine the masonry and then suspend it? It's just a story, a story of concern, a story of for imagination, and then the product is what you see. So so these are some few sketches. And this is also a very interesting project, very structurally inspired. Is an architect's office in Bangalore, wherein we thought, let's look at, through the analogy of nature, how do I make a concentration through portals, and then I create two structures. One is suspension, one is a steel structure on the top, which becomes their office, and then two suspension from these portals. So portals have been independently structured to be stable. Okay, so we have designed this shape in such a way that it doesn't require a tie; it becomes a monolith, and it also helps at the ground level to park the cars column free. Okay, and then you suspend from the portals these two floors, okay, in steel, and then you span the structure, you span the diaphragm for the upper structure. Okay, so it's this is how it is. If you look at on the left hand side, the structure is built two suspensions, okay, which becomes the floor, and all these elements which we have used as a structure is all simple angles what you see every day. you know when I look at an angle, from an angle I can create a Z section. Okay, I can create a channel, then I can make an eye. Okay, then I can make a C. So these two angles, which are dual in nature, moves in different direction for the purpose and the force it needs to carry. Okay, so that is how we have created this. So two are going in side by side, but it has doing different purposes at different location to cater the force at that point. So it's I think I can call it, when you look at the structure, it looks very poetic in the sense, you can to an extent you can feel the force. You can feel the force which is going through. So so you see this building, so you see the suspension, then you have the two floors on the top, and you can park the car anywhere. So if you see the first slide, all the members, even though it is spanning 40 feet, the members are small, it's all 75 angles. Yeah, you can see the 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 left image. It's all very thin. This is achievable only when it is in tension. So we also so every 6 months, when every year you have architects for the interns. So we also try and then see if they can build as part of their exercise. Okay, so every year we are managing group of architects to look at a structural concept and then probably, you know, start exploring through materials and start building. So this is a project which is an outcome of one of the exercise. We created a pod through the group of architects who are inspired through engineering, okay, to create a space. So these are some of the photos. Actually, I'm doing my uh, you know the lecture through in the pod right now. Yeah, just some few images, which is in the night and is in the day. It's about 7 feet by 7 feet by 7 feet by 10 feet. It's about 70 square foot. It has a toilet. It has a sleeping place for one person. It has a ledge for doing some work, and it has a small kitchenette where you can uh, eat whatever, you can heat something, and then it has a exclusive bar. It has a good bar. Okay, so everything is uh, very very compact, and it has a perforated floor. The floor is fully perforated so that I can see basically from the bottom who is coming, everything, but the air can pass through. And to protect the mosquitoes, we have a mesh below that. And when you look at the bottom, this whole pod is invisible. It's not visible because of no surface. And the top surface is totally illuminated by Dempelon sheets, so that you get actually the movement of clouds. You can see, you are almost like as though you are almost floating. And these are some of the projects which I wanted to show it to you. Is these are steel. We do a lot of steel structures all over India. We do houses. So technology, in the sense that how do, if the client comes because he has chosen the steel, so his requirement is to build the building in 100 days, is a challenge. So how do we start looking at design to suit that, is one of the challenge in the office. So we take the challenge and then innovate. So we create columns and capitals as part of the structure, and then start assembling the floors. You know, so each column and capital is 2 floors, sometimes it is 3 floors, taken through 100-ton cranes and erected, and then you just assemble these elements, put the decking and concrete. So we finish almost 50,000, like say 50 or 1 lakh, 2 lakh square foot of structure in just 100 days. In all, uh, to totality. This is one project which is almost finished. This is a software building. Then I will show you a project which is a biotech. It is it's like you are growing steel. It's like you have an end column, you have a corner column, you have capital. This is about 3 lakh square foot project, which is going in a full pace. And each column is about 10 tons, which is erected through crane. And you can erect about 8 columns with 2 cranes, in a day. So imagine the pace at which we can finish this project. This is about 8-story building, and it's going at high speed. People are working into, because we have to finish this by May. This is an ongoing project, so I thought I'll show it to you. Yeah, thank you.
Yeah. Thank you so much, Manjunath. Can you please unshare your screen so we can see you again? Yeah, it was really fantastic to see, and the way you started. There are a lot of uh, dual concepts, duality. So there is seen, unseen that you see in the nature. So there is something that is visible, and you try to see what is going behind in terms of the forces, in terms of the growth, and you try to observe something. Then there was another kind of a duality where you say that okay, there is a dreaming, and then there is a coming back. And when you come back, you try to sketch and put down those things, right? Then there's another duality that you mentioned, necessity and the greed. You know, what I it appears to me that usually when we come across structural engineers, most of the time either they are largely focused on what is the seen or what is the visible, that one part of it, and not many a times they would like to go behind and try to get into the other extreme. And that was something that I thought was unique in your presentation, and that is getting reflected in many of your projects. The fact that there is so much richness in these projects is because that unseen aspect has found its manifestation. So I think I would like to hand it over to Professor Gurdev, Professor Bhairav, anyone who wants to jump in and start the discussion. Please feel free.
Okay, well, let me start now. I think it's an excellent experience going through all the slides. Very enjoyable.
Thank you.
Particularly the way you represent nature and bring it together, how you see the forces in nature and try to bring into the structure here. I have two questions. Many, but we can discuss later. But two.
Right. Yeah.
One which is to do with the very recent, toward the last few slides that you have shown.
Right.
I think it's a great idea that you have this column where the shear capital is attached with it and you kind of install it. And then the floor is added. It almost reminds me of the construction technology which was used in Scandinavia and Canada way back in 60s, like a lift slab system
Right.
where the slabs were made on the ground, a capital, steel capital was added, concrete slab was casted, and then when the winter came, they would remove the dome which was controlling the temperature and lift the slab to 10, 15 floors up there.
Fantastic. Yeah.
When I saw that, I almost felt initially that you're going to make all this on the ground and just have two cranes and lift the whole thing up to the column. So that way it would kind of make your construction very simple. Why is it that you are only putting the capitals and doing all the construction up there rather than lifting the whole thing up there?
Yeah. See. See what somehow the my this was when I got this project, so to do it in steel. To me, there are two things which are very important in the sense that fabrication through controlled environment and erection as part of the site. Okay, so how do I bring a skill which is basically working through discipline? There is a discipline, there is a rigor. They're not supposed to think. Okay, and the same people who are doing this work through discipline should get an enlightenment that they belong to this creature what they created. Like say, in the sense, how does discipline and enjoyment come together? Was my very important in the sense that I want to give back to the people who are part of this whole process. Okay, so what I thought was, I will not explain the whole building to the people. Okay, let me create a curiosity in the fabricators that you make 10 tons of column. I need a space. I want to fabricate everything at controlled. I check all the weldings. I check all the alignments, everything. You start erecting it. Okay. So you also 100% as a fabricator, you are not seeing this monolith as part of your, as part of your site, you know. So then when it goes to the site, I'll take them, come and see your structure. It is in a vertical alignment. They say, wow, sir, how does it stand? How can you connect it? These are questions which is being asked by them. Okay. Then, then there is a particular order to create connecting these capitals called as strips, basically shear strips. Okay, it's like a flat slab in steel. Basically, it's a flat slab in steel. Then I create it. Then I weave purlins. The purlins are woven. So what is happening is this compression, this bending member is made up of three elements. One is the compression member, one is the tension member, then there is a shear component between the two members. Okay, the shear component is the space for the purlins to move through. So the purlins are always continuous. It's not simply supported. It's continuous. Okay, it is spanning over this. Okay, and one more thing, what we also did is always capitals. The capital strips are all short span followed by a large span. So when there is a rhythm, a short span, a large span, a short span, a large span. So what is short span doing? It is taking the negative moment to control the positive moment. So the balance of forces on top and bottom is controlled by the flanges of these sections. So I use it very efficiently. I don't use a I beam predominantly for bending flange. Then the depth has to increase. So I use it for both the forces. Okay. So then third is I use the compression flange as a channel which basically seals the decking slab, then the concrete. So the compression is held down by the flanges. So you don't require a shear connector. So this thought process has dictated this part of structure. Okay. So when they walk on the flat strip, so they have to have temporary supports from where they lift at 6 meters purlins and then erect it. You don't require major crane for that. You can put a tripod and then erect it, because these columns becomes support for anchors. You can hold it and then assemble it. So there are only 4-5 people are required to assemble all these members. Okay, so actually the whole site has very less members who are very skilled, and then it's very interesting to see.
Thank you. Thank you. Bhairavji, please.
Okay. So, first of all, I would like to ask, before even I proceed, that you have mentioned some amazing quotes, during your presentation. I have listed some of them down, like sense of gravity is important when you are dreaming anti-gravity. Then you have said gravity is the hidden geometry of space. So I would like to know what is the source of this quotes, or have you engineered these quotes yourself, just like the structures you have mentioned?
No. These are quotes. This is not neither an architect or an engineer. Okay. This is neither an architect or an engineer. This quote I got from Riaz Tyagi. He sent me. Manju, have you seen this quote? Gravity is the hidden geometry.
Yeah.
Quote. And he said he's a Nobel laureate, he's a physicist. So I was just, I thought it's just, it's like what is gravity, like hidden geometry. Okay, it's fine. But it didn't stop there. It didn't stop there. It just held me and very curious. I was very curious. So that day, my life changed. So then I started looking at things in a very, very wider perspective. I started thinking more as a very open, looking at sky, looking at sun, looking at solar system, looking at things which are not seen. Even though it was bothering me, but now it gave me a great comfort to look into this, and then I have to I look at this and then create buildings to suit that. So the second quote is mine. So it's like I said, it's a continuation of the same. You know. So it's yeah.
So that I would like to ask again that uh, the kind of work that you have done is of course part of structural engineering, but we can very clearly see that there are a lot of inputs which are not directly related to engineering. So where does that come from? I mean, what do you do apart from engineering? I mean, do you read something, or where do you get all this? Uh,
No, I don't. I don't read much. I don't read much. Okay, I don't read much. But yeah, I think my morning hours are very good in the sense. So I live on coffee. So when you are, I observe. I observe. I observe. Then I start going beyond what I'm observing, and then probably and relate it. No, I think it's very. There's a lot of things which you learn from history. I think you have to go back to history to see, to check, a lot of things. And second thing is nature has been a companion to me in all respect. So so this is and debates with architect. What else? Like you I think they take you to the crazy world, just to get into. So I think I'm fortunate enough to work with uh, great number of architects all over the world. You know, they help me to share, so we debate, we discuss with a great vigor, and and it's fantastic. I think it's not about. It's like there is so many thought processes which we share, and it's an outcome of that. It's an outcome of that. Yeah.
Another thing I would like to ask is that these days structural design has
Yeah.
become you know process of do's and don'ts,
Right. Right.
right? Unfortunately, for example, you have said that thinness can be
Yeah.
expressed beautifully into a structure, but
Right.
there is so much focus on compliance, and codes always specify minimum thicknesses,
Right.
right?
Right.
So there is that for an engineer, uh,
Yeah.
you know thinness can be scary
Right.
in
Right.
a way. So
Right.
how do one come out of this trap?
Yeah. See, I think quotient of fear, the quotient of fear has a relation to the depth of our questioning. You know, say for example, the thinness, the lightness, also is dictated by stiffness. Is also dictated by stiffness. So how do you look at lightness as part of a force? You have to see that as a force. It's very relative. It's very relative. You have to pull it. It has to be through tension. It can be a wire. Okay. So if I use a wire, and if the wire is accessible, somebody can shake it. The building also will shake. So even though structurally it may be okay, but is it okay to make this accessible? These are questions which we need to look at. And there are a lot of cases where we are questioning the codes. See, I think I tell most of the architects is codes are for the masses. Codes are being done for the mass. If you want to innovate, you need to courageous to question the code. Okay, that is when innovation happens. Okay, if you want to safeguard, if you want to be very safe, and if you want to follow the codes, then there is a pattern to the structure. All the structure will look same, because the code dictates the form finally. Correct?
Yes.
It dictates the form.
Yeah.
So I think there's nobody in the world can say that you need to have only two. Now the code says 300 column. Now code says you can't have stop columns. So the reason why people, I think there is a problem with our education to a great extent is education has become it's not a need base anymore. Education is not need based because we have too much of money with us. So after B, the same engineer will go to ME, continuous. After ME, he becomes PhD. Okay. So it is a continuous buying of education. When you are buying education, where are you evolving? Where are you giving time for evolving, you tell me? And the same guy will come to teach. If I don't get jobs, I'll go to teaching. So this I think this is what is the problem today in India is if you ask an MTech guy, fresher MTech, just ask him what is density, okay, and then what is the density of steel, and he says that steel is less weight compared to concrete. He says because he is confused with volume. He is not. You understood? So he says steel is lesser density than concrete. Okay, why? Because he is confused with volume. So he is more interested in what he is seeing. He is not getting into the depth of what he is not seeing. Because he has not touched steel in his life, nor he has touched brick in his life. Okay, so this is the problem. But anyway, we find we fight with IITs, we fight with IICs, we fight with NITs to prove our own point. But it's a struggle, no problem. But it's you have to go through that. So it's education for them, but for struggle for us.
Okay. Thank you.
You know,
We have time to ask one small question of you.
please, sir, go ahead.
Very, very small question. I very much appreciate the
Hello?
Sir, you are mute.
Yeah.
I like to go refer the very early slides which you have shown, showing
Okay.
forces of nature.
Right.
And I have seen there are a lot of trees. If you go into the Kutch area here, bowel trees would start twisting. The entire tree would be twisting, and when you cut them, your grain will go twisting because the tree has been put under a force, and there was a twist there in the tree.
Right.
And
Right.
they freeze in the stem. When you cut them, you can see the twist. And
Yeah.
so I want to know because you've been talking about the gravitational force, but
Right. Right.
I think an equally important, of course, you are considering all that,
Right.
but you didn't mention equally important is the force which is perpendicular to the
Right.
gravity.
Right.
Or perpendicular or more as perpendicular, which is the wind force and
Right.
other
Right.
things.
Right.
So when you apply that, for example, when you were talking about the Kochi Benelli Dome,
Yeah.
I would like to understand when the wind comes, why would this dome not become uh, 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 not leave its shape and try to go like that with the forces coming? I think that would be very interesting to also see. I'm sure you have considered all that, but
Right. Right.
I would like to know as from you that when you talk about the gravitational forces, it will be nicer if you're also talking about
Yeah.
the forces which are perpendicular to the gravity, which are
Right.
coming.
Right. See, I think, as long as any building on this earth, any building on this earth, okay, is a cantilever. Okay, is a cantilever. Okay, it is supported at one point and free. Okay, there are two forces which come into picture to make that as cantilever. Okay, one is fixity one is horizontal force. Okay, as what you said. Okay, so horizontal force come to become predominant as you go higher. The cantilever height increases.
Very much reflected by
Okay,
the
yeah,
Eiffel.
by the height. Okay, when the height, when you are going higher, the forces which was not acting, okay, suddenly becomes prominent, like wind, everything comes into picture. Okay, so what I'm saying is when the building is smaller in scale, okay, smaller in size, okay, the anchor on the ground is more than sufficient to hold the horizontal forces. Okay, as you go higher and higher, okay, the vertical forces, the gravity becomes a problem because gravity doesn't create, but the anchor helps you. So whenever you are going a tall building, okay, see the beauty here is the tall building requires more car parking space. Okay, any tall building for that matter, you require the floor area is very less. Okay, the floor area is less. The load per square meters of the floor area is very high. So you don't get the spread of the footing for the concentration of the load. The SPC is much low. So you have to go deeper. You have to go deeper to get the SPC. Okay, you go 20-meter deep or 15-meter deep. So what are you doing? You are going deeper for a better SPC because the area is less. Then automatically what you are getting is also the anchorage. What does this anchorage do? Create stiffness for the verticality against horizontal force. Okay, so there is always a connection, the right connection as a right support for a particular structure. Okay, now to answer your question, in especially in Benale building, what we created was a form which has a periphery which is interwoven diagonally. You see my columns, all the columns are interwoven. Okay, two columns had connection to one column in the outside periphery, so that only the uplift is held by the periphery one member, compression is held by two members, which are diagonally placed. So the whole structure was diagonally placed for the horizontal forces. The periphery was like braced, and then because of the brace, it has some amount of cantilever. Okay, to an extent. Okay, this cantilever was only temporarily due to erection. It was like a hoist. Once you completed the curve, the cantilever vanishes. It becomes a vault. Okay, that is the whole thing.
Thank you.
Yeah, I think you were talking about the engineers and the BTech, the the problems in the current way of the education. I think the pretty much same is true when I talk about the architectural education these days also, because I'm sure most of these buildings, and this is something that also we were discussing earlier when the interview was starting, the fact that uh, in all these projects, you are not coming towards the end just to sit and do calculations as and just give the drawings for the execution of the frames, but you are involved pretty much from the beginning of the project, right from the conceptual stage, and trying to discuss. And you are not coming just as a consultant, but you are pretty much as a part of the team with the architect. And that is when actually I think a lot of this can happen. And it's evident in the projects that you could see. And so the question that I'm coming to is that it's for an architect, for somebody who is an architect, for me to sit and have this kind of a conversation, this kind of a discussion with an engineer, I need to come out of my shell of an architect and come on that platform. And also, I need to think about all these things that you have mentioned. I need to think about the seen unseen. I need to be aware of all these basic principles that you are talking about. Then I think something meaningful can come about. So it's equally important that how the architects are trained, how are they taught structures, how are they taught construction. I think once these, as an architects and engineers, are taught the basics of, and in that sense, I think the initial years, the founding first years, second years are extremely important. How they are taught structures, particularly, and construction. And that is, I think, what I take away. There's a student who have asked a question regarding. I would like to include. Shrey is asking, "Sir, thank you for such a great presentation. You deviate from the conventional way. How would you suggest new graduating architects can do so and not get caught in the rigid loop of current practice?" Can you please elaborate?
Very difficult question in the sense that I think the very important thing here is you need to question what you like. Very basic question. What you think is beautiful for you. What is that? What is these words mean? Like beautiful. I love this building. You need to question, or you need to sensitize this whole system in the sense that uh, I like the work of Peterson. You know, I like the work. So what do you like in that? Why do you think that you like it? Okay. So these questions are very important for somebody to grow. This will create hunger. The hunger is not something what we don't know. Hunger is basically a set of questions. I think you need to answer. The questions always doesn't lead to answers. The questions will lead to more questions. I think that actually gives you a path to come out from the mundane stable system to systems which you actually want to do. You know, so it is only through questioning. You need to that I think that has happened for me for the like I understood myself at the age of 50. I took so many years to come back to this position. In the sense, there is no ready-made, that you have to look at this. You have to go through that. So till 50, I was doing the same thing. I used to do apartments. I used to do, but I was finding why I don't like it. So you have to answer to all these things. There is a reason why you don't like it. You have to get into that. You know, there's nothing wrong. If you don't like it, you don't like it. But why is the question? You know, don't think that there is an answer. There is one more few set of questions waiting for you. You know, so the life is all about questions.
Fantastic.
Yeah.
Fantastic. There's one more question. I think partially it's been covered, but maybe if you want to elaborate on that. Avia is asking, can you please elaborate about the process through which you decide construction sequence of the project with strict timelines?
Yeah, I think it's about we have to look at whether it is realistic. I think first we should look at realistic, and then we have to talk about materiality, and is it genuine? The somebody who is asking, is it genuine to take it as a challenge? Is something which we have to look at. And then you have to go through a lot of, you have to discuss with the contractor. You should look at methodology and materiality, and then accordingly take a decision. you know and then there could be changes in aesthetics, so we have to talk to the architects, and if there is a free hand, we can look at all these things. But but uh, but uh, but it's a process. It's a process which is an outcome of a debate. You need to discuss with everybody.
Yeah. Yeah. I think I'm really thankful. Thank you so much. Uh, it was really wonderful presentation. Very, very exciting to see your work, and a lot of interesting questions and ideas have been discussed towards the end. So I would like to, I think, end here and summarize this at, you know, I think as architects and as engineers, I think maybe a lot of things we could go on and discussing, and this debate could, uh, go on. But there is definitely one takeaway, one very strong takeaway that we can see is that, if you just accept plainly anything that is thrown at you, you will just end up doing what people have been doing. If you accept the codes, for example, we talked about the codes. So if you just accept the codes literally, you will end up doing what is specified. It's only when you come out of that, you take a risk, when you start questioning what is existing. I think then slowly a new ways and a new processes can emerge, which can then lead to a lot of fantastic explorations. So I think there is a lot of learning in here in for the students for architecture, engineering, and also us practicing architects in their fantastic lot of inspiration. And I'm really thankful to you, Manjunath, for giving us your valuable time and coming to ArchiDiaries, sharing your work, sharing your experiences. And also, I'm really, really thankful to Professor Gurdev and Professor Bhairav. Thanks to all of you.
Thank you once again to everybody. It was pleasure, sharing some of my works. Thank you.
Yeah.
Thank you.
Thank you.
Thank you.
And so, thanks, Bhairav. Thanks, Gurudev, sir. Thank you, Ashna. And I would also like to thank all the people who have joined with us on YouTube and Facebook. And just like to announce that we are left with two more interviews in this series. Next Saturday, we will be joined by architect Manish Gulati from MOFA in New Delhi. So I hope to see all of you back on next Saturday. And let's hope that we can keep this wonderful conversation